Hi everyone, this is just a really quick video on how to simplify radical expressions. So given a radical expression, I will be able to express it in simplest radical form. So basically we're just going to be talking about simplifying radical expressions. Let's go over some quick definitions. So say we have this right here. You probably call this as like square root of 7, or maybe you've heard radical 7. Either way is fine. So this whole thing right here is called the radical. And everything inside the square root symbol is called the radicand. So this can include numbers and variables and whatnot. So anything that's inside the square root is the radicand. And here's a rule to remember for these upcoming examples. Let's say you have the square root of a times b. That's equal to the square root of a times the square root of b. So these are equal expressions. And the question to think about when simplifying radicals is the following. What is the biggest perfect square that divides into the radicand? And here are some examples of perfect squares. A perfect square is any number made by squaring a whole number. So for example here, 25 is a perfect square because 5 squared equals 25. 36 is a perfect square because 6 squared equals 36. So when you're looking at radical expressions, think about the biggest perfect square that would divide into the radicand. Here's our first example. Express the square root of 40 in simplest radical form. So we're going to simplify this by using the idea of perfect squares. So I have the square root of 40, or radical 40, and then I think about the number 40. What's the biggest perfect square that can divide into 40? So for example, 36 is a perfect square, but I can't divide that into 40. And then I go down a little bit. 25 is a perfect square, but that wouldn't work either. 16 wouldn't work. 9 also wouldn't work. But 4 is a perfect square and it also divides into this number 40. So I'm going to write it out as factors. I have the square root of 4 times 10, which is the same thing as the square root of 4 times the square root of 10. 4 is a perfect square, so I can further simplify this to 2 times the square root of 10. I technically don't need that multiplication dot, so I've simplified this. I went from the square root of 40, which is simplified into 2 times the square root of 10. Let's look at another similar example. We're going to express the square root of 63 in simplest radical form. So the square root of 63, I focus on the radicand, 63. What's the biggest perfect square that divides into 63? I go through my list of perfect squares and notice that 63 is divisible by 9. And 9 is a perfect square. So that's going to work out. So I can write this out as the square root of 9 times 7. I can split this apart into the square root of 9 times the square root of 7. Square root of 9 is a perfect square. It's 3 times the square root of 7. So I've simplified this into 3 times the square root of 7. Let's look at one more quick example. we're going to express the square root of 12 in simplest radical form. So here we're going to focus on the radicand, which is 12. And I think, what is the biggest perfect square that divides into 12? 9 doesn't work, but 4 does. So let's write this out. We can break it down into the square root of 4 times 3. Let's split it up. The square root of 4 times the square root of 3. And the square root of 4 is 2. So we just have 2 times the square root of 3. This is the simplified form of the square root of 12. So this was just a very quick lesson talking about how to simplify radicals. When simplifying a radical expression, keep this question in mind. What is the biggest perfect square that divides into the radicand? Great work today, and I'll see everyone in the next lesson.